Hello friends, welcome to Innovative Shiksha. So today I bring to you the next video in the important MCQ series. So today we are going to discuss class 11 physics chapter number 2. So in this video we are going to discuss one important MCQ and one important special length units. So before checking the answer, please try to solve these MCQs by yourself and then check with the correct answer. So to gain the maximum benefit out of this, you can take the proper notes also for future references. So let us start with today's MCQ. The first MCQ says parallax method is used to determine which of the following. Your options are: option A is estimation of very small distances, option B is measurement of mass, option C is measurement of large distances, and option D is measurement of time. So out of these four options, you have to choose the correct option. So here for question number 1, the answer would be your option number C, that is measurement of large distances. That is, parallax method is used to determine large distances, right? So let us try to understand what is the parallax method. So I'm going to explain in brief what is parallax method. So basically, as I have already told you, we are going to use the parallax method for measurement of large distances. So let us suppose we have to measure a distant planet S, which is very far away from us, right? So what we have to do, we have to take the observation of this particular planet from these 2 points. So let us suppose we are taking the observation from point A and point B, right? So the distance between point A and point B, we are denoting as small b, which is known as basis, right? And then the distance between the observation point and the planet is denoted by capital D, and the angle subtended by these two particular point is known as theta, which is also called as parallax angle or parallactic angle, right? So we have a particular relation between B, D and theta, and by that relation we can find any distance, right? So what is that relation? So that relation is capital D equals to B upon theta, where D equals to distance of a far away planet S, and small b is distance between the 2 points of observation, that is this particular point. And theta, as I have already told you, theta is parallax angle, which is measured in radian. So this is how we can find any large distances, right? So let us come to the next session. So next session will be about spatial length unit. So these spatial length unit are very useful while solving particular problems, basically in physics. So let us try to understand what is the spatial length unit. So the first spatial length unit is Fermi. So 1 Fermi, which is denoted by 1 F, is equals to 10 to the power minus 15 meter. Okay. So the next one is 1 angstrom, which is denoted by 1 angstrom, which is equals to 10 to the power minus 10 meter. Okay. So the next one is 1 astronomical unit, which is denoted by 1 AU. And what is that astronomical unit? It is basically the average distance of the sun from the earth, right? Which is equals to 1.496 into 10 to the power 11 meter. Fine. The next one is 1 light year, which is denoted by 1 LY, which is equals to 9.46 into 10 to the power 15 meter. So how we can define 1 light year? Basically it is the distance that light travels with a velocity of 3 into 10 to the power 8 meter per second in 1 year. As you know, the velocity of light is 3 into 10 to the power 8 meter per second. So how much distance light travels by this velocity in 1 year is called as 1 light year. So the last one is 1 parsec, which is equals to 3.08 into 10 to the power 16 meter. So how we can define parsec? So the parsec is the distance at which average radius of Earth's orbit subtends an angle of 1 arc second. So this is how we define parsec. So I am explaining again. Parsec is the distance at which average radius of Earth's orbit subtends an angle of 1 arc second is known as the parsec. So these are some spatial length unit which you should remember, and this will help while solving the problems. Thank you very much.